Okay, question number 5. The diagram shows a circuit used to measure the capacitance of a capacitor. So this is kind of circuit. Okay. Now the reed switch vibrates between the two contacts. So this switch will vibrate. So it means that it will be vibrating like this, to and fro like this. Okay. So I call an eraser to erase it. Okay. Wait. Okay. Now with a frequency of 50 Hz. Okay, on each oscillation of the capacitor is fully charged and totally discharged. Okay, so the current through the milliammeter is about 225 milliamp. So A, calculate charge the flow of the capacitor each time it is discharged. Okay. B, calculate the capacitance of the capacitor. C, calculate the current through a milliammeter when second identical capacitor is connected in parallel, and number 2 is in series. Okay, so number 8, I want to find what is the charge. Okay, what is the charge, the flow of the capacitor each time it is discharged. Okay, so first thing is I need to find my time. Okay, why I need to find my time? Because I know that charge will be equal to IT. Why? Because it's given here. The reading of a milliampere is 225 milliamp. So I should have my I equal to 205 times 10 to the power negative 3. Okay, so this is 225 milliamp times the time. Okay, so the time is 1 over f, which is the frequency. So it's 225 times 10 to the power negative 3 divided by 50. Okay, 50. So I should have 4.5 times 10 to the power negative 3 coulomb. So it means that each time it will carry about 4.5 times 10 to the power negative 3 coulomb of charge, discharge, and charge and discharge. Okay. Now B want to find what is the capacitance of the capacitors. Okay, so back to the question again. I have a the potential difference here is 9 volt, means that the capacitance here is charged up to 9.0 volt. Okay, so from the equation, C equal to Q over V. Okay, so Q is what I have calculated here, 4.5 times 10 to the power negative 3 coulomb. Okay, the V is 9 volt, so I should have 500 microfarad. Okay, 500 microfarad. Okay, now C part 1. Part 1 say that if I place another one here, which is a parallel, okay, so I draw it up. So I place another capacitance over here, which is parallel to the original one. So this is my ammeter. Okay, so this is my ammeter. So the question asks you, what is the reading? Okay, what is the reading of the current through the milliammeter? So first thing is I have to find my total capacitance. So since this is a parallel circuit, so my total capacitance is very simple, just to add it up. It's 1000 microfarad. Okay, now then I will know that what is the total charge that we carry of these two capacitors. So Q equal to CV. Okay, so will be 1000 microfarad. Okay, times the potential difference is 9, so that I should have 9.0 times 10 to the power negative 3 coulomb. Okay, now I want to know my current. So the current is very simple, is Q over T. Okay, so it's 9.0 times 10 to the power negative 3, divided by time. So the time here is 1 over 50. Okay, so I should have around 450 milliamp. Okay, so this is part 1. Now if part 2, the question says if I connect another one in series. Okay, so means I connect it in such a way. Okay, so what is the current going through of these two capacitors? So again, I have to find my total capacitance. So this is a series, so my total capacitance will be 1 over 500 micro plus 1 over 500 micro. Okay, inverse it, so I should have 250 microfarad. Okay, now then my charge, the total charge of this between these two capacitors will be 200 times 10 to the power negative 6 times the potential difference between the two capacitance, so that I should have 2.25 times 10 power negative 3 coulomb. So finally my I is Q over T. Okay, by replace 2.25 times 10 power negative 3 divided by 1 over 50, so I should have 103 milliampere.